9.3 is going to talk about this idea of the converse of the Pythagorean theorem. So we already know what the Pythagorean theorem is. You guys have had some exposure to it in the last section, but also in
middle school.
Middle school, exactly. Yeah. So the Pythagorean theorem was what?
That when we have a right triangle,
yes,
then we knew that c squared was equal to a squared plus b squared.
Perfect. Okay, so the converse would be basically flip-flopping that, right?
Okay, so this is saying that if c squared equals a squared plus b squared, then we know that it will be a right triangle.
Okay, so this is exactly one thing I want to stress about this section is this is going to help you prove what kind of triangle we're going to have, right? We're going to start with right triangles, and notice it says Theorem 9.5, and we put in parentheses right triangles because this is going to help you prove when it's a right triangle, okay?
Okay.
It says if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Now, notice the wording is a little different than what Ms. Hochgraby said, but we highlighted down here kind of what she said.
Right.
If c squared, so in other words, c has to be the
longest side.
Now, we don't know
if it's a hypotenuse.
If that's the hypotenuse. If it ends up being it, then that means this is a true statement. C squared is equal to a squared plus b squared.
So if it's true, then that will be the hypotenuse.
Exactly.
We just know it's the longest side, but the longest side should be what side we're talking about with the hypotenuse.
Now, how do you know what's going to be longest side? Well, they're going to give you 3 measurements, and the one that's the biggest is the longest side. Okay? So just kind of keep that in mind. And then the A and the B are the other 2 sides. Okay? So if the Pythagorean theorem, basically this equation is true, c squared is equal to a squared plus b squared, then we know it's a right triangle, which then essentially means c is the hypotenuse, which means which angle would be the right angle?
That angle C
would be,
so which is across from the longest side, should be
so
your
you
right
would be able to tell a little bit more about those things.
Okay. Sounds easy enough. All right, so first questions say, do the given sides form a right triangle? So let's go along with the kind of logic that we just laid out for you. Okay. So looking at just this first example here, which side here would have to be, if this was a right triangle, which would be the hypotenuse?
The longest side, so it would be 13.4.
Okay.
But we don't know it's a hypotenuse yet.
We don't know that it is. We're just saying if it was a right triangle, that would be the hypotenuse. That's what we're trying to find out is this a right triangle? So how am I going to write out my equation?
Well, I'm going to start with 13.4 because that's your C, and they're going to square it. And I'm going to put does it equal 7 squared plus 10 squared. And the reason why I say does it equal, because we don't know. Right. We don't know for sure if these are equal, because if they are, then it would form a right triangle, but they might not. Right. So we'll do 13.4 squared, I'm sorry, is 179.56. And then that's going to get, what, 49 plus 100, so 149?
Right.
That's okay to write that way?
Sure.
So those are obviously not equal.
Okay, so what does that tell us then?
Not a right triangle, so no.
All right, so all we're looking for is, does the c squared equal the a squared plus b squared?
Okay.
All right, let's check the next one.
And why don't you guys try this one on your own? Okay, try it and then check.
All right, now looking at this one, how do you know which one is the c? Because we've got a radical in here too.
Well, I could just type in C6 radical 5 in my calculator, right?
Absolutely.
The other thing to kind of keep in mind is radical 5 is actually bigger than radical 4. So 6 times something bigger than 2 would be greater than 12. So that has to be the longest side.
Exactly. And it ends up being like 13.1 or 42, I think, or something like that.
So yeah, that's my C.
So that's what we want to start with.
So we're going to put 6 radical 5 squared.
Notice how I had to put some parentheses around there. How come?
Well, if you didn't, so get rid of those parentheses real quick. Let's just see what it would look like. If you wrote it exactly how I said it, Ms. Hochgraby is just jumping ahead.
I was, and then I thought about it. I'm like, we need to have this.
I often hear, and I know Ms. Hochgraby hears, people just say 6 radical 5 squared, just like I said. What are you only squaring, though?
Then you're only squaring the radical 5.
But we want to square the whole entire thing, so we put parentheses around it.
All right.
So we're going to say, does that equal 6 squared plus 12 squared?
Okay, so 6 radical 5 squared.
So that would be squaring the 6, which would be 36, and then squaring the radical 5, so that'd be 5. So 36 times 5 is 180. And we're going to see, does that equal? Okay, so 6 squared plus, so that'd be 36 plus 144. That is 180. So that is equal. So yes.
Yes, they do form a right triangle. Awesome.
Notice again, I want to go back with what Ms. Huckabee did. She first decided what's your C, all right? So what is the longest side, and then kind of work your way through that, right? Now, before we move on, okay, this one we obviously is a right triangle. I want you to think about this and make a prediction of what kind of triangle this is going to be, all right? So it can't be right. So my other options would be what?
Well, we could have an acute triangle.
Could be acute.
Could have an obtuse triangle.
It could be obtuse.
And looking at those sides, obviously we're talking about angles because we know it's scalene.
Yes.
So we're thinking angles.
Yeah. So it's something to keep in mind. Notice, given the side lengths, only can actually determine what kind of triangle it is based on its angles. So the fact here is, notice this C squared is not equal to A squared plus B squared. But notice C squared ends up being
larger.
So think about, maybe make a prediction. We're not going to say anything just yet, and we'll see if your prediction is correct. So,
moving on to our next theorem.
Next theorems. Okay, now this one, notice what is in parentheses. Kind of, we put that there because this is going to help you prove it's an acute triangle. Okay, so let's read it. It says, if the square of the length of the longest side of a triangle is less than, so the square of your longest side is less than the sum of the squares of the other two sides, then the triangle is acute. So essentially, what we have highlighted, I think, is kind of the helpful thing. If you know C squared, and again, C is always the longest side, is less than A squared plus B squared, then the triangle is acute. Now, does this make sense?
Sure, less than seems smaller, so acute seems smaller. Now, one thing we want to point out here, you have to start with C squared.
Yes, I'm glad you said that.
And this is where kids will say, oh, I always wrote it as A squared plus B squared equals C squared.
Yeah.
That is wonderful, because all you've done before is just Pythagorean theorem.
Yeah.
But when you're trying to line these up to talk about, are they acute, or eventually we're going to be talking about obtuse, and you can probably see where we're going to be going with that too. But we really need to start with the C squared in order for that logic to happen, okay?
Exactly.
In order to see the less than means acute.
Yes. And is C in this case going to be a hypotenuse?
Not necessarily. Well, actually, it won't be if it's acute, because it's not a right triangle.
So the key is, again, I love what she just said. Make sure you start with the longest side, and you're always comparing it to the other two sides squared added together, okay? So this is in case would be an acute triangle. Now, hopefully you're already predicting what this next one's going to say.
Yes.
So if you have the square of the longest side, again, notice it always starts with that C squared, and it's greater than, this time, the sum of the squares of the other two sides, then the triangle is obtuse. So again, highlighted. In this case, if C squared is greater than A squared plus B squared, then the triangle is obtuse.
Right, because the angle's greater than 90.
Now, going back to that one slide, could you tell me now which type of triangle this one is?
Yeah, that must be an obtuse triangle, because that C squared is greater than.
This ends up being greater than the A squared plus B squared.
Love it.
So that's kind of the things you're going to be doing. So you're either going to have a right triangle, which is, those are a little more we're comfortable with, or acute or obtuse. But remember, again, start with the C squared, longest side, greater than A squared plus B squared, or maybe less than.
Okay.
All right? We just don't know.
All right, so we've got a couple examples here, and it says, can the given side lengths represent a triangle? So the first we just need to decide, are they even triangles? Now, I'm going to stop there, and we're going to keep going on with the rest of the directions in a minute, because the rest of the directions go along with what we thought about this chapter. But what does that even mean, Mrs. Palermo? Can these sides even form a form a triangle?
I'm thinking back in first semester. So it's been a while.
It's been a while.
Just because I give you 3 numbers doesn't mean they're going to always form a triangle.
Right.
We know that the sum of any two sides has to be greater than the third.
Right.
So if I add any two sides together, they have to be greater than the third. So like on this one, the 8 and the 18 has to be greater than the 24, but we don't know for sure until we do it. So 8 and 18 is what, 26? So that's greater than 24. So but that's only one scenario. So we got to check each scenario to see if it actually works.
So like 18 plus 24 has to be greater than 8, which that obviously is.
It is, okay. 8 and 24 has to be greater than 18. Which that is going to be true too.
Yeah.
So yes, it is going to make a triangle. Now, does that mean it's a right triangle? No, it just means it's a triangle. Right. We're now having to decide what kind.
Right. And we're going to come back and do that in a minute. Let's go ahead and do that same thinking real quick.
Okay.
On the second one, just to make sure we're comfortable with the is it a triangle idea.
Okay.
Okay. What do you notice about this one?
So if I do like 2 plus 12, is that greater than 10? It is. It works.
Definitely.
If I do 2 plus 10, that is equal to 12. That's not greater than. So this is not a triangle.
Okay. Just something to be aware of. Look for the is it a triangle first.
If they ask the directions. Yeah. Like that first problem we did, it just says, does this make a right triangle? So if they're asking that, then you can go straight into it. But since it says, is it a triangle first, we need to make sure, because it may not be. Because what if it's not? Do I need to go and then go classify it?
Well, no. If it's not a triangle, you can't classify it as anything because it's not a triangle.
Exactly.
So this one, we're just going to stop right here. I just want to make sure we understand the difference because I knew we had one of both. Now, let's keep reading the directions. It says, if they can, so this one can form a triangle, we're going to classify the triangle as either right, obtuse, or acute.
Okay.
So let's go ahead and let's classify this one.
All right. So since it's a triangle, we are going to now, the way to do it is I got to take the largest side or longest side, which is your C, and that's going to be 24 in this case. And I'm going to square that. And I don't know. Am I going to leave it blank?
I'm going to leave it blank too.
Because we don't know if it's equal to, it might be greater than, it might be less than. And then I'm going to do 8 squared plus 18 squared.
So in this case, we're not just saying, is it right? We're trying to decide what it is. Okay, so 24 squared is going to give us
576. And then 8 squared plus 18 squared, that adds up to 388. And so that is greater than, so that means this is an obtuse triangle.
Love it. So yes, it's a triangle. It's an obtuse triangle.
And I know on some of the classwork, they're going to ask you the same directions. So we're going to be expecting to see your support from it is a triangle or it's not. So that first part. And then showing me support of what kind of triangle it is.
And guys, yes, we expect to see your work. Don't just say, oh, yes, obtuse. We want to see the work. And notice that we're not showing every single step here.
No.
But we do want to see that you've put them into the idea of the Pythagorean theorem, even though it's not truly the Pythagorean theorem. Just comparing the c squared with the sum of the squares of the other two sides. And what is your simplified answer? Showing
us that this is greater than that, or this is less than that, or this is equal to.
Okay, so we've got a couple more.
Okay.
All right, what do you think about this one? What do we need to do first? Same direction, sorry.
Oh, same directions. Okay, we got to first decide if it's a triangle or not.
Right.
So let's add 16.4 plus 20.5, and we're going to see is that greater than 12.3, and it is.
Obviously, because 20.5 by itself is, okay.
16.4 plus 12.3.
See if that's greater than the 20.5, is it?
And it is. It's 28.7.
Okay.
So that
works. And then we have one more left to check.
20.5 plus 12.3. Is that greater than 16.4? And it is.
Yeah, obviously because 20.5 by itself is even greater. Okay, so yes, this is a triangle.
So we can go ahead and decide what kind.
Let's classify.
So we'll take the longest side, which is 20.5, and square that. And we're going to see, does that equal, or is that greater than?
Yeah,
leave it blank. 16.4 plus 12.3, each of those squared, sorry.
Yep, I figured you were going to come in and say that.
So this, on the left side, it's 420.25. And then those add up to 420.25 as well.
So what can you tell me?
This is equal, which means it's a right triangle.
Love it. Last one, same directions. And guys, I would encourage you to try this one on your own.
Yes.
Okay.
All right, let's just determine if it's a triangle first. So 41 plus 10, that is greater than 40.
Definitely.
So that's one scenario. What about 41 plus 40? That's obviously greater than 10.
Yes.
What about 10 and 40 added together? Yeah, that's greater than 41. So it is a triangle.
Okay. And since it is a triangle, let's classify.
So it'd be 41 is the c squared. So 41 squared. And is that 10 squared plus 40 squared? We're going to, again, determine what it is. So 41 squared is 1,681. And then on the other side, it's 1664. And that is greater than, c squared is greater than, so that's obtuse. And again, guys, if you don't put c squared first, what you're going to risk is you're going to maybe say it's a cube, because you're going to say...
You're going to see the less than
basically,
sign.
You're going to see this written over here. You're basically going to see it flip-flopped. And it's easy to kind of make that mistake, so be careful with that. Okay?
Yeah, just start with your longest side each time. Okay.
All right, what about this problem? It says, given points P, Q, and R form a triangle PQR. So we know that these form a triangle. It says, decide whether the triangle PQR is right, acute, or obtuse. So we're not deciding, is it a triangle? They're telling you this makes a triangle, but what kind?
Okay.
So notice they're giving you coordinates. Does that mean we have to immediately graph on a coordinate
no,
plane?
And they don't say to graph. Are we going to be doing the distance formula?
Why would you be thinking using distance formula?
Because we've been looking at side lengths of a triangle, and we don't have any of the side lengths, but we have some points, and we know to find the distance between those 2 points, we're going to need the distance formula.
So we don't need a graph, and graphing only just allows you to kind of see the picture. So what I would do, I would just draw a triangle, and we don't know what kind of triangle it is. And I'm just going to label, okay, P is a -1. Is that 2? Yeah.
Yeah.
Q is 4, 1. And R is 0, -1. And again, I didn't even graph this.
Just a rough sketch.
Just a sketch. Yeah. So we know what side lengths we're trying to find.
Okay.
Okay. So we're going to have to use the distance formula how many times?
3 times.
Now that only finds the side lengths of the 3 sides.
And then we'll have to check see c squared compared to a squared.
So in the end, we're going to have to decide this. Okay, but that's the second step. So the first step is let me make a note. We're going to use the distance formula. And then the second step is we're going to do that. So there's 2 parts to this.
Okay.
All right. So what do you want to find the distance of first?
Let's do PQ. So we are going to take the square root of, let's do 4 plus 1 quantity squared plus 1 minus 2 quantity squared. So that's going to give us a 5 squared will be a 25, and a -1 squared would be a 1. So radical 26.
And I like that you're just saying radical 26. You don't need to necessarily look at simplifying it, and don't even put it in your calculator and get a rounded answer.
Yeah,
okay?
just
we are not. No longer are we just getting a rounded answer. And what's nice is because we're going to put it in this formula theorem in just a little bit. So I'm going to go back and label this. This is going to be the square root of 26.
Okay.
All right.
So let's do PR. Okay, so for PR, I'm going to take the square root of, let's do 0 plus 1 quantity squared and -1 minus 2 quantity squared. So that's going to give us a 1 squared is a 1, and a -3 squared would be a 9, so radical 10. And let's leave it again as radical 10.
I love it.
Okay. We have one more side to find. This isn't really that bad.
No.
Okay, let's do QR.
It's stuff we've done before. That's what's kind of convenient about it.
You know, it's funny. We did this like our first chapter. Like it was early.
It was early.
Okay.
On.
So here we go. We're gonna take. Let's do 4 minus 0 quantity squared plus a 1 plus 1 quantity squared. So that'll be a 4 squared to a 16 plus 2 squared would be a 4. So radical 20. All right, so now I know the side lengths, and I need to determine how to c squared compared to the a squared plus b squared. And I know the longest side here. The nice thing about not simplifying any radicals, it's very easy to determine. The longest side is the radical 26.
So this is going to be your c.
That's the C. So the question is, does radical 26 squared, how does that compare to radical 10 squared plus radical 20 squared? And what's really awesome is all the squares and square roots cancel. So 26, how does that compare to my 10 plus 20? So 30.
So we have 26
is obviously less than
30.
So it's acute.
So the answer to this is acute.
That was not too bad.
So it has quite a bit of work involved, but guys, it's using distance formula, which we're comfortable with, and using this converse of the Pythagorean theorem that we're comfortable with as well.
And again, the nice thing too, that all the squares and square roots cancel. So that's really going to be helpful for you too.
Perfect.
All right. Last one says to classify the quadrilateral and provide support with work and explain. All right, this is going back to the end of last semester, where we talked about quadrilaterals. Yes. And let's just review some of the things that we remember about quadrilaterals.
Okay. Well, we know like it could be a parallelogram, it could be a rectangle, it could be a rhombus, it could be a square, it could be a trapezoid, it could be a kite. I mean, all sorts of options here. But what I'm thinking, while she's kind of hinting at that kind of stuff, I'm noticing in the picture that the diagonals are bisecting each other. And that is a characteristic of a parallelogram. Okay,
so I know I'm somewhere in this category.
And I even noticed that the diagonals are, it looks like they're congruent.
They would have to be, right?
Yeah, because if they're all bisecting and they're all the same, so that could be a rectangle, right?
Correct.
Okay. So the question is, could it be a square? And so what I'm thinking, this is what I'm thinking. I know in a square the diagonals are perpendicular. So not necessarily in a rectangle. So the question is really, do we have a right triangle? So that there is the connection to this section. So if you are focusing on just one of those triangles, the sides of that triangle are a 1, another 1, and a radical 2.
And I'm going to just redraw that.
And yes, guys, I know it kind of looks like they're perpendicular, but we need to support it with work. Notice this.
Yeah, we can't assume from a
Okay,
picture.
so I'm going to use the converse of Pythagorean theorem. So I'm going to take the longest side, which is radical 2, and square that. And we're going to see really, essentially, if it is equal to 1 squared plus 1 squared, because we're really wanting to see if they're perpendicular or not.
Right.
So that's going to be 2 on the left side. And then on the right side, it's also going to be 2. So it is equal. So that is forming a right angle, which means that it's going to be a square.
Now, can I just say square because it forms a right angle?
No. Okay, so my explanation would be what would be, like I started off by saying the diagonals were congruent because that was given.
And that means that it is definitely a
rectangle or a square. Okay. Then I found what I supported.
And really, actually, before that, you even just said it was a parallelogram because the diagonals bisected each other. So I'm going to add that up here. Diagonals bisect each. Oh dear.
Start over.
Bisect each other. So that is a parallelogram. Okay. Then we said the diagonals were congruent, so that was a rectangle or square.
And guys, I said this without any work so far. I was able to narrow it down, and so I was using that. Now I found the diagonals were perpendicular, which means a square.
Yeah, because it really means that it's a rhombus, but you already knew it was rectangle, so therefore it's a square. Now, did I really use a lot of sentences and stuff to explain that? And that's okay. We just want to know, what do you know about it, and what does that tell you? And so really seeing those properties.
And the reason why we want the work is to support why the diagonals were perpendicular. That's supporting that part.
Yes.
The other two stuff that we wrote was already stuff we knew from the picture.
Definitely.